So let's look at some example problems with acceleration. A roller coaster car rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. 3 seconds later, at the bottom of the slope, its speed is 22 meters per second. What is its average acceleration? So let's write out the information we know. Meters per second, that's a speed or velocity. That's the starting speed or velocity, so we call it VI. The final speed or velocity is 22 meters per second. The time is 3 seconds, and we're looking for the acceleration. Next, I would write the formula. Acceleration equals v final minus v initial over t. So our acceleration in this case, now start plugging in our values, 22 minus 4 over 3. So 22 minus 4, 18, divided by 3, and we get an acceleration of 6 meters per second squared. Okay, and the next problem, try this one on your own, and then by the easiest way, press pause, and then come back and press play again, see if you got the right answer. So if a Ferrari with an initial velocity of 10 meters per second accelerates at a rate of 50 meters per second for 3 seconds, what is its final velocity? So here are given values: initial velocity, 10 meters per second, acceleration, 50 meters per second squared, time, 3 seconds, and we're looking for the final velocity. Our formula, acceleration equals v final minus v initial over t, or rearranged, v final equals v initial plus at. And that will actually be a little easier to solve, so let's use that one. V final equals 10 plus 50 times 3. So V final equals 10 plus 150. Final velocity here, 160 meters per second. Okay, here's another one for you to try. A skateboarder is moving north at a speed of 40 meters per second and comes to a stop in 5 seconds. What is the acceleration of the skateboarder? Press pause, try this on your own for a second, and then once you have an answer, press play again and see if you got it right. Okay, the data were given: the initial velocity, 40 meters per second. Now, here's where you don't see a number, but you have a piece of data. Stop. We know stop is a final velocity of 0. So sometimes you'll see a word in a problem that is actually telling you a piece of data. Stop, at rest are two very common examples of that, meaning 0 velocity. The time is 5 seconds. We're looking for the acceleration. Acceleration equals v final minus v initial over t. So acceleration equals 0 minus 40 over 5. So our acceleration is negative 40 divided by 5. So our acceleration of negative 8 meters per second squared. Remember, in this case, our final velocity, our final acceleration, is negative. And we said that anytime the acceleration and velocity are in opposite direction, the object will be slowing down. Here the object is slowing down from 40 to rest, so it should have a negative acceleration. Here's another problem. Give this one a try. Okay, our starting information, initial velocity of 20. And acceleration, it is slowing down, so we know the acceleration must be negative. We want to figure out when it comes to a stop, so the final velocity would be 0, and we're looking for the time. Here it's probably easiest to use the VF equals VI plus AT. So 0 equals 20 plus negative 4t. 4t, add 4t to both sides, equals 20. T equals 5 seconds. So here we've had a number of example problems dealing with the concept of acceleration. Direction of acceleration is very important. We need to understand the basic concept.